Unit 5, Question 10. The question states, the hypotenuse of a right triangle is 14 centimeters in length. Find the measures of the unknown angles in the triangle that will maximize the perimeter. So first, this is the triangle. X, Y, it's a right angle triangle, and these are the unknown angles. We can start by finding this angle. And the first step that we have to do to make it easier is to use trigonometric ratios to replace x and y with. So for example, the sine of theta is the opposite over hypotenuse, which is y over 14. Now to isolate for y, we would multiply this by 14 so that these two cancel out. And what we do to one side, we do to the other. So the y will become 14 sine theta. And then, since we found y, we can now find x. For x, we can use cos so that it is adjacent over hypotenuse. So the cos of theta, the one that we want to know, is x over 14. And then we do the same thing that we did in the previous step. So 14 cos theta is equal to x, because these two cancel out. From here, we can take the perimeter formula, which is just adding up all the sides, which is 14 plus x plus y. And since we have found a substitute for y and for x being these two, we can substitute that in. So the x would become 14 cos theta plus the y would become 14 sine theta. And then finally, we can start by taking the derivative. So the derivative of 14 would just remain 0, and then the derivative of 14 cos theta would be, the 14 would stay the same, but the derivative of any cos would be negative sine. So this would become negative 14 sine theta plus 14, and the derivative of sine anything is cos. So cos theta. So what it gives is negative 14 sine theta plus 14 cos theta. And then we can set it all equal to 0. And then the next step is we can move this negative 14 sine theta to the other side of the equal sign, so that it becomes a positive, just like so. And then it would be equal to another positive cos theta. And now to isolate for 1, we can take either side. So we could just do this. So to simplify it, we just divide it by itself, and what you do to one side, you do to the other. Just like so. So this would become 1, since the 14s, they cancel out, and then cos over sine is cotangent theta, or in other words, 1 over tan theta. To make it a little simpler, we multiply this so that these two can cancel out, and then just do it to the other side. So really, tan theta would be equal to 1. Now, using a special triangle, that can help us determine this one, the only one triangle can help us. To find the tan, which is sine over cos, it would have to be the opposite over adjacent. So if we were to choose any of these angles, it would be opposite over adjacent, or vice versa. Therefore, tan of pi over 4 would just be equal to 1 over 1. So tan pi theta, or pi over 4, sorry, is equal to just 1, which is the same as we got. Therefore, we have figured out that the angle can only be pi over 4. And since theta is equal to pi over 4, and that this is a right angle triangle, since theta is 45 degrees, then the other angle is also 45 degrees. Therefore, the angle that will maximize the perimeter is pi over 4, or 45 degrees.